Hi everyone, I'm Lap-Loi Chung from the National Center for Research on Earthquake Engineering. Welcome to the course Seismic Evaluation and Retrofit of Structures, offered at the Department of Construction Engineering, National Taiwan University of Science and Technology. The topic of the lecture, Reinforced Concrete Jacketing 2. Reinforced concrete jacketing is a common method to upgrade the seismic performance of a building structure. And in this lecture, an example is given to demonstrate how to assign hinge parameters for the column after retrofitted with reinforced concrete jacketing. This is the information of the original column. It's 30 centimeter in depth, 45 centimeter in width. And after reinforced concrete jacketing, the depth is increased from 30 centimeter to 60 centimeters. And the width of the column is increased from 45 centimeters to 75 centimeters. And here's the information about the reinforcement, the longitudinal reinforcement, and the transverse reinforcement of the original column. And here's the reinforcement for the jacket, longitudinal reinforcement. There are totally number 6 rebars. And the transverse reinforcement is a number 3 rebar with spacing 10 centimeters. And the height of the floor, 3.5 centimeters, and the clear height of the column is 3 meters. And the design dead load, that's the dead load, the actual load of the column under dead load and half of the live load. PU equal to 17 ton force, and the moment strength of the original column is 12 ton force meter. The compressed strength of the original concrete, FC prime equal to 190 kgf per cm square, and the yielding strength of the steel of the original column is 3200 kgf per cm square. With reinforced concrete jacketing, the compressed strength of the reinforced concrete jacketing is increased to 280 kgf per cm square. For the reinforced concrete jacket, the longitudinal steel, the yielding strength is 4200 kgf per cm square. For the transverse reinforcement, the yielding strength is 28 kgf per cm square. For the reinforced concrete jacket, first of all, we discuss the force displacement relationship under fractal shear failure. We use 4 points: A, 0, 0, that's the origin, and B, delta Y VM, and C, delta FS VM, and D, delta A 0. And VM equal to 2 mm divided by HC. Mm is the moment strength of the column. For the original column, we start from point B. Point B, the second moment of the column gross cross-section area of the original column equal to BH cubic divided by 12. And here's the result. And the concrete elastic modulus equal to the empirical formula. By applying the empirical formula equal to 15,000 times square root of FC prime equal to something like that. And the column fractal rigidity with the consideration of cracking equal to 0.35 EOC, the elastic modulus of the original column, times IG. IG is the second moment of the original column. And that's the value here. And delta equal to delta Y equal to Vm divided by Kc. Kc is the fractional stiffness of the column, equal to 12 EIC divided by HC cubic, equal to 3 point something ton force per centimeter. And Vm equal to 2 Mn of the original column divided by HC, equal to 8 ton force. After reinforced concrete jacketing, for point B, that's the second moment of the column cross-section area after reinforced concrete jacketing, equal to something like that. And the elastic modulus of the jacket equal to something like that. And the compressed strength is increased from 190 to 280. And the fractional rigidity of the concrete equal to something like that. And then we can calculate the fractional stiffness of the column with RC jacketing. Kc equal to 52 ton force per centimeter. If we go back to the previous line, the original column, the stiffness is 3 ton force per cm. And after reinforced concrete jacketing, it's increased from 3 ton force cm to 52 ton force per cm. That means that the stiffness has been increased a lot. And delta equal to Vm divided by Hc. Vm equal to 2 times Mn original column plus Mn of the jacket divided by Hc. And V equal to 41 ton force. If we go back to the previous line, the lateral strength under fractional failure of the original column is 8 ton force. With reinforced concrete jacketing, it is increased from 8 ton force to 41 ton force. It increased a lot after retrofit. And then we move to point C. For the original column, the y coordinate equal to 2 mm divided by Hc equal to 8 ton force. And then the column depth H equal to 30 centimeter, and the effective depth is approximated to be 80% of the column depth equal to 24 centimeter, and the column width equal to 45 centimeter. And the shear stress Vm is the lateral strength under fractional failure divided by BD equal to 7 ton force per square centimeter. And the cross-sectional area of the shear rebar equal to 0.71 times 2. There are totally 2 legs, so that for one leg the cross-sectional area is 0.71 centimeter square, and then multiplied by 2 equal to 1.42 centimeter square. And the volume ratio of the transverse reinforcement equal to AB divided by BS. S is the spacing of the transverse reinforcement equal to 25 centimeter. Therefore, rho W pi can be come up with 0.00126. And then we can calculate delta Fs for the original column. At this displacement, the failure mode transforms from shear failure to fractional shear failure. And this is the formula to calculate delta Fs divided by Hc. And the final result is 0.029 something. Therefore, we can calculate delta equal to delta Fs equal to 8.77 centimeter. After reinforced concrete jacketing, for point C, AB equal to 2 times 0.71 for the original column. And for the jacket, AVJ equal to 2 times 0.71 because it's a number 3 rebar and there are totally 2 legs. So that AVJ equal to 1.42 square centimeter. And the width of the original column is 45 centimeters. After reinforced concrete jacketing, the width equal to 75 centimeters. And then we can calculate the volume ratio of the transverse reinforcement. It consists of two parts. The first part is for the original column, and the second part derived from the reinforced concrete jacket. After the calculation, rho double prime equal to 0.003 and something. And this is the depth, effective depth of the original column, and the effective depth of the RC jacketing increased from 24 centimeters to 48 centimeters. And the shear stress equal to 2 mm divided by BDHC divided by 133 square root of FOC prime. Here is the compressed strength of the original column, plus the second term contributed by the reinforced concrete jacket. And the final result is 0.008 and something. And the depth of the original column equal to 30 centimeters, and the depth of the reinforced concrete jacket HJ equal to 60 centimeters. And for the component, for this term, NU divided by something, it becomes something like that. And this is the term contributed by the original column. This is the part contributed by the jacket. And the final result is 0.0003 and something. Finally, we can calculate by using this empirical formula. We can have delta Fs divided by HC equal to 0.03 something. And then with this term, we can calculate delta Fs equal to 10.19 centimeters. And V equal to Vm equal to 41 ton-force. And the last point, for the moment nonlinear hinge, point D, theta equal to the minimum of 65 degree and arctangent HC divided by H equal to 65 degree. And the depth of the core concrete of the original column equal to 21 centimeter. And then by using this empirical formula, we can have delta A divided by HC equal to something like that. And then by comparing with the lower bound, the final result for delta equal to the maximum of delta Fs and delta A equal to 14.58 centimeters. At point D, the strength of the column vanishes. And after RC jacketing, and theta remains the same, equal to 65 degree, and the concrete depth and core concrete depth of the original column is 21 point something centimeters. And for the concrete, the core concrete depth increased to 48.9 centimeters. And then by using the similar empirical formula, we can calculate delta A divided by HC equal to 0.044 something. And then delta equal to maximum of delta Fs and delta A equal to 13.35 centimeters. Okay, finally we have the force displacement relationship for the original column. Point A, point B, point C, and point D. And then we make the physical value to be normalized to non-dimensional values. Therefore, point A 0, 0, and point B 0, 1, and point C A 1, and point D B 0, and A equal to 0.02 something, B equal to 0.04 something. And the moment scale factor is the moment strength of the column, 12 ton-force meter. And the rotation scale factor equal to 1. And here is the nonlinear hinge parameters for the original column, the moment nonlinear hinge. And A 00, B 01, and C 0.02 something 1, and D 0.04 something 0. And the moment scale factor is the moment strength of the column, 12 point something ton-force meter. And the rotation scale factor equal to 1. That's the original column. After reinforced concrete jacketing, we also have the force displacement relationship, and then we normalize it so that we can come up with the hinge parameters A and B. And the moment scale factor is the moment strength of the column after reinforced concrete jacketing is 50 ton-force meter. If we go back to the previous line, the original column is 12 something. And after retrofit, it increased to 50 something ton-force meter. And the rotation scale factor remained to be the same, equal to 1. For the column with reinforced concrete jacketing, here is the hinge parameters, point A 00, point B 01, and point C 0.007 something 1, and point D 0.004 something 0. And the moment scale factor is the moment strength of the column with reinforced concrete jacketing, equal to 50 ton-force meter, and the rotation scale factor equal to 1. So far we have completed the moment nonlinear hinge. Now we move to shear nonlinear hinge. After reinforced concrete jacketing, the shear strength becomes VC plus VJC. J stands for jacket. That's the shear strength of the concrete of the original column. Shear strength contributed by the concrete of the jacket, plus VS, original column, plus VJS. That's the contribution by the jacket. For the original column, VC equal to 0.53 times 1 plus NU divided by 140 AG times square root of FC prime times BD. After some manipulation, we can come up with VC equal to 8 point something ton-force. And the shear strength contributed by the concrete of the jacket, VJC, equal to 0.53 times square root of FJC prime, that's the compressive strength of the jacket, multiplied by the cross-sectional area of the jacket, equal to BJ DJ minus BH, equal to 19 ton-force. If we go back to the previous line, we see originally of the original column equal to 8 point something ton-force. And after reinforced concrete jacketing, it increased from 8 something ton-force to 19 ton-force. And VS, the shear strength contributed by the transverse reinforcement of the original column. And here's the formula taken from the concrete structure design code, equal to VS equal to 3 point something ton-force. And then we move to the shear strength contributed by the transverse reinforcement of the jacket. VJS equal to something like that. And the final result is 19 ton-force. If we go back to the previous slide, Vs of the original column is 3 point something ton force. After reinforced concrete jacketing, it is increased to 19 something ton force. The degrees of increase is a lot. And then with the strength information, and then we can move to the force displacement relationship, and we use 3 points to describe the force displacement relationship under shear failure. And point A, 0, 0, and point B, Vs, delta S, Vn, and point C, delta A, 0. Delta A, we have the lower bound, delta S, and the upper bound, 0.04 Hc. For the original column, under shear failure, point B, delta equal to Vn divided by Kc equal to 3 point something centimeter. And V equal to Vn, that's the shear strength of the original column, equal to 12 something ton force. And point C, by using the empirical formula, delta A divided by Hc equal to 0.04 something. And then we can come up with delta equal to delta A, and the lower bound is delta S, and the upper bound is 0.04 Hc. And in this case, the upper bound control equal to 12 centimeter, delta equal to 12 centimeter, and V equal to 0. At this point, the strength of the column disappears. And after reinforced concrete jacketing, point B, delta equal to Vn divided by Kc, and Kc is the stiffness of the column after reinforced concrete jacketing. Therefore, it is composed of 2 parts. The first part is contributed by the original column. The second part is contributed by the jacket. And delta equal to 0.98 centimeters. And V is the shear strength after reinforced concrete jacketing, 51 ton force. If we go back to the previous line, for the original column, the shear strength is 12 something ton force. After reinforced concrete jacketing, this increased to 51 something ton force. And point C, we have delta A divided by Hc equal to 0.04 something, and delta equal to delta A with lower bound delta S with upper bound 0.04 Hc. And in this case, the upper bound control and delta equal to 12 centimeters, and V equal to 0. Okay, with the force displacement, and then we can reduce to hinge parameters by normalizing the physical quantity to be a non-dimensional quantity. And V is normalized by the shear strength Vn, and delta is normalized by the clear height of the column. And for the original column, the force shear strength is the shear strength of the original column is 12 ton force, and the displacement scale factor is the clear height of the column, 300 centimeters. And we can summarize the hinge properties. A equal to 0, 0, point B 0, 1, and point C 0.04, 0. And the force scale factor is the shear strength of the column, 12 ton force. And the displacement scale factor is the clear height of the column, equal to 300 centimeters. And with RC jacketing, and similarly, we can have the force displacement relationship, and then we can transform it into non-dimensional quantity, and the force is normalized by Vn, and the displacement is normalized by the clear height of the column. And Vn is the shear strength of the column with RC jacketing, equal to 51 ton force. if we go back to the previous slide, for the original column, the shear strength is 12 ton-force, and after jacketing, it is increased a lot to 51 ton-force. And the displacement scale factor, HC, is the clear height of the column, equal to 300 centimeters. And then we can summarize the shear nonlinear hinge by this table. Point A, 0, 0. Point B, 0, 1. And point C, 0.040. And the force scale factor is the shear strength of the column with reinforced concrete jacketing, equal to 51 something ton-force. And the displacement scale factor is the clear height of the column, equal to 300 centimeters. And here's some reference for this lecture, some videos. And in this lecture, we demonstrate how to calculate those hinge parameters for moment nonlinear hinge, for shear nonlinear hinge. And then this information is necessary for detailed evaluation for the structure after reinforced concrete jacketing, after retrofitted with reinforced concrete jacketing. And we use a column as an example to demonstrate how to assign moment nonlinear hinge and shear nonlinear hinge. That's all for this lecture, and the video of this lecture will be uploaded in this channel. Thank you. See you next time. Bye-bye.